Yes, I can see.
Okay, 1 minute. Right. So I think we did up to this one, right? So part B, 6 part B. Okay. So next part is we have so next part they're saying that for each of the following values of AB, find the largest number that is not of the form ax plus by. Ax plus by, where both x and y are non-negative. So the first one is AB. The pair is 3, 7. So if you remember, uh, if we see the last equation, right? So here we have 3x plus 5y, right? So 3x plus 5y, what you saw is any number greater than equal to 8, we can express in this form, right?
We can express yes.
Right. So the largest number in this case that cannot be expressed where both x and y is non-negative is 7, right? 7 is the number that is the largest that cannot be expressed in this form where both an x and y are non-negative, right?
That is because only since 8 you can build all the numbers from 8 by
Yes, yes.
using 3x plus 5y. Okay.
Right. So similarly, here they are asking what is the largest number when this is the pair. So 7 and 3. So here we have 3x plus 7y. So what is the largest number that is that cannot be written in this form? So that is what they are asking.
I mean, if you just do like x equal to 1 and y equal to 1, I mean,
Yes.
then that would be 10, right? And then,
Okay.
I mean, I'm
Well,
not sure if from there, from 10 onwards, you will be able to get all the numbers, 10, 11, 12.
yes. So you can try that. So for example, you are saying if I put x equals to 1, y equals to 1. So then the number
Yeah,
is 10, right?
seems like it's not possible.
Yes. So 10 is possible because I can write it as 3 plus 7 or 3 times 1
Hmm.
plus 7 times 1. But what about 11? Can you write 11 like this?
No, it's not possible.
Yes. Then to how to get it? So we have to give a general thing, right? So that after this number, everything is possible.
So, I mean, above in the first time we did the 3x 5y, I mean, we just guessed, like,
Yes. So the
we
thing is,
didn't.
yes, you have to see the pattern why it is working. So that is the thing. So 5x, 3x plus 5y, we saw that 8, 9, 10 up to we can go. Everything is possible up to 15, and then we saw that after when it is 16 or more, we can use this previous from 8 to 15 to get the expression. So similar something you have to show for this case also. That
So maybe,
hmm.
if we keep going upwards, like, I don't
Okay.
know, maybe somewhere, some number, let's say, maybe from 13 and above.
13 hours. So okay. So okay, 11 is not possible, that we saw. Then 12, what about 12?
Yeah, 12, yes. 3 multiplied by 4.
Right. So 13?
13, 2 times 3 plus 7. 14, 2 times 7.
14?
14, 2 times 7.
Right. So yes. So yes, can we claim that after this everything is possible? So that is the question.
From, I mean, I'm not sure.
So from this onwards, right?
Okay.
So what you can do is, okay, so at least these three numbers are working, right? 12, 13 and 14, right?
Yeah.
So any number, okay, okay, so the thing is, so any number, suppose C, that is greater than equals to 15, right?
Yeah, but
Okay,
what about 16? 16 doesn't work even.
16, okay, let us check. 16 is 3, 13, then 10. So 16 minus 7 is 9, right?
16. Oh, yeah, 16 is possible, right? 16.
Yes, 16 is possible. So 15 is this one. 16 is, I think, 3 times 3 is 9, plus 7 times
7,
7,
1.
right? Yes, 16 is possible. 17 is also, I think, possible because 14
Yeah,
plus 3, right?
yes. Oh, I see. Okay.
Right. So I think after 12 everything is possible, but somehow we have to prove it, right?
Okay.
Right. So what we can do is, so at least 12, 13, 14 I know that it is possible, right? So if I want to show that any number bigger than 15, greater than equals to 15, we can also write. So what to do, right? Suppose C is any number bigger than equals to 15, right? So
Okay.
I can always subtract a multiple of 3, right? To make it below 12, 13 or 14, right? So what I wanted to say is, so any number C, so this is equal to 3 times some Q, right? 3 times some Q plus the remainder I have, right?
Okay.
So since C is greater than equals to 15, I always have Q to be at least 5, right?
Yes.
Right. So this is fine. So what I can do is I can take out 4 from here. I can take out 4 from here plus 12, right?
Yes.
And R, what is the range of R? R is either 0, 1 or 2, right?
Yes.
Right. So 12 plus R I can combine together, right? So any number C, what I can write is, so since Q is greater than equals to 5, this Q minus 4 is always positive, right?
Sorry.
So from here, Q greater than equals to 5, right? So this from here it follows that Q minus 4 is always positive, right?
Yes.
Right. So now, so it is 3Q, right? And since it is R is 0, 1 and 2, right? So these are the only case, right? So it is plus 12 or 3Q minus 4 plus 13 or 3Q minus 4 plus 14, right? So these are the only cases, right?
Yes.
But I know what are the expression for 12, 13 and 14. Each of them I know the expression, right?
You know
Right.
the expression? What do you mean?
Expression means in terms of 3 and like this, 3 and 7. What is the linear combination? We know, right?
Right.
Right. So what I can do is in the next step. So this is 3Q minus 4 plus. So this is 3 times 4 plus 7 times 0. So this is 3Q minus 4 plus 3 times 2, 7 times 1, and 3Q minus 4 plus 3 times 0 plus 7 times 2, right?
Yes.
So now we can combine. So it is 3q, or we can write 3 times q plus 7 times 0, and here is 3 times q minus 2 plus 7 times 1, and 3 times q minus 4 plus 7 times 2, right? So we have shown that any number that is bigger than equals to 15, I can write like this in terms of 3 and 7, 3x plus 7y, where both of them are greater than equals to 0.
Okay, but how? I mean, why did you start? Why did you say? I mean, why did you start by saying c greater than equal than 15 and not, let's say greater than equal than 12?
Right. So the thing is, we have to. So here we saw that 11 is not possible, right?
Mm-hmm.
So 11 is not possible. So we have to look from 12 onwards, right? Whether it is possible or not, right?
Uh-huh. Yes.
So after if you check from 12 onwards, so we checked 6 numbers, right? 12, 13, 14, 15, 16, 17, like that we checked, right? So here you can check, you can see that the remainder, the multiplication of 7 is repeating, 0, 1, 2. Here also 0, 1, 2, like.
Yes.
So this is some sort of periodic in 3 terms, in 3 variables, because also the one condition is that 3 is the smallest number, right? So we can actually combine the numbers after that in sets of 3, like this. So that's why I looked at the first 3 numbers, 12, 13, 14, that is continuous. All of them are expressible in 3x plus 7 by form. And then from 15 onwards, I express each of them in terms of the previous one. So 12, 13, 14. So that is the proof, right?
So you're saying because 15.
So difference
So
between
you're
15
saying.
and 12 is 3, right?
Yes.
So if I take any numbers along this sequence, that is 12, 15, 18, 21, every term the difference is 3, right?
Every time the difference is 3. Let's say 12 and 21.
No, every term is consecutive terms.
Yes, every yes, they are consecutive terms.
Right.
Okay.
So every consecutive terms, their difference is 3, right? So similarly, 16, 13, 19, every term is difference is 3, right? Consecutive.
Okay. In that row, let's say.
Right. So whatever I can express any number in this sequence, if I go like this, is something 3 times something this 13, right? Because the common difference is 3, right? So this is in an AP, in an arithmetic progression, right? This sequence.
Yeah.
Okay.
So you need a reminder because you need a reminder in order to have like another variable to
Yes.
have values.
Yes. So the remainder is required, right? Because that will only make sure that what are the possible remainders, and you will have the cases for that. Because we are dividing by 3, 3 is the smaller number. So there will be three possible remainders, 0, 1, and 2.
Yeah, I mean, if you choose 12, you will not be able to say r is equal to 0, 1, and 2. You need to choose 15.
Yes.
Okay. And what would be the largest number?
So here answer will be
That is
11,
not.
right? So because they are asking the largest number that is not of the form, and I cannot write. So the answer is 11, right? So for this one it is 11, right?
Okay. I mean, but for that we just guess, like we didn't derive that from the conclusion, like from the formula.
No, conclusion from here actually what we saw that any number that is greater than equals to 12, I can express like this.
Okay,
Is
you made a proof for
right.
that.
We proved that any number that is greater than equals to 12 has this expression 3x plus 7y, where both x and y are non-negative. So the largest
Okay.
number is 11. Right?
Okay.
One more let us do, then it will be clear. So for example,
Sure.
so next one is part 2, or you can do the part 3 also. So here the pair is 4 and 11.
4 and 11.
So 4x plus 11y. So what is the largest number?
Okay, we can try.
Yes.
So maybe
So any number will start from, it is at least 11, right? Because 0 1 if we put, then it is 11. So it has to be bigger than 11, right? Right. So what I wanted to say is I can put 1 0, then I have 4, right? And 0 1 if I put, it is 11. So any number between 4 and 11 we cannot express. So you have to start looking from 12 onwards, right? Whether it is possible or not. So 12 is possible. 4 times 3. What about 13?
13 is not possible.
Right, 13 is not possible. 14, is it possible?
14, no, it's not possible.
No. 15?
15, yes.
Right, 15 is possible. So 4 times 1 plus 11 times 1. Right, like that, can you check which ones are possible and which one are not possible?
27, I think is not possible.
27, why? 20, okay, so 27, right? So if I subtract 11, then it will be 27 minus 11 is
16?
16. Then it's possible, right?
Oh, yeah, then it's possible.
Right.
Entonces, 25.
25. 25. Okay, so if we subtract 11, I have 14. Yes, 25 is
14.
not possible, right? Because 14, if I subtract, yes. So 25 is also not possible. 26 is possible.
26, yes.
Yes. What is the expression? So 4 times
4, 1, 11, 2.
27 we saw it is possible. 27 is 4 times 4 plus 11 times 1.
It's 11 times 1. So it seems
28.
like from there, maybe it's possible.
Right. What about 29?
29, 1, 2 times 4, and 2 times 11.
2 times 4 is 8.
Then,
No,
then
that
it's
is 30.
29. 29, no, maybe it's not possible. Yeah.
Wait, 29 is not possible. Okay, let us see 30 onwards what is happening. So
30
30,
is not.
yes, 30 is if I subtract 8, right? So that is 22. So 4 times 2 plus 7 times 4, right? No, not 17. 4, 1 minute. 8, right? So
No, it's 11 by 2. 4 by 2, 11 by 2.
Right. So then 31.
That would be 4 times 5, 11 times 1.
Right. 32 it is possible. So 4 times 8.
8.
33 is also possible.
11 times 3.
Right. So yes, the claim is yes. I think after that everything is possible because we found 4 consecutive numbers, right? That is expressible. Right.
So you're saying since we found 4 consecutive numbers,
Right. So once we find 4 consecutive numbers, that is expressible. So any number after that, I can put it into this sequence, right? So
You
one
can
sequence will
express.
be so
So you're
30.
saying. So you're saying since you have the 4 consecutive numbers, let's say 34 would be equal to 30 plus 4, for instance.
Yes.
And then 35 would be, okay, I see. So, okay. All right.
So like
So,
that I can. Right.
I see what you mean. Yeah.
So any number which is we can again do the same thing. So C is we can write it as some 4Q plus R, right?
Yes.
Right. And C we are taking C is greater than equals to 34, right?
Yes.
So if C is greater than equals to 34, then what is the value of Q? So it is at least 8, right?
8.
So Q is greater than equals to 8, and R is either 0, 1, 2, 3, right? So what I can do is Q minus 7 if I take 1 minute. So right. So if I take Q minus 7, then I can get 28 plus R, right? No, that will not help. 1 minute. So if I have 4 times 8, right? So we can take, I think 8 also we can take. So 34, right? So if I divide by 34, if I divide by 4, how many times it go? 32, right? 7, 8. We can take 8 also, that is fine. And then 32 plus R, right? Okay.
So you're saying.
So 32 plus R. So actually it will be better if I do like this. Okay, let me tell you. So this is also fine, but the easier way is if I know that if I find 4 consecutive numbers, then after that everything is possible. So it will be easier if I start with a multiple of 4. So we can use this one. So next term is 34. So 34 is how much? What is the expression?
That
So
would be 4 times 3 plus 11 times 2.
Right. 35 will be
4 times 6.
right.
10 times 1.
So this is expression. So I think we can start from here. So any C that is greater than equals to 36. Yes. So Q is has to be greater than equals to 9. So now I think it is fine. So if I make Q minus 8, then it will be 32 plus R, right? And since R is your R is 0, 1, 2, 3. Right. So since your R is 0, 1, 2, 3, I have these 4 options. Q minus 8 plus 32. 4 into Q minus 8 plus 33. Right? And so on. So now I know that every time I can express, right? Like the previous one, right?
But 31, how are you going to get 31?
No, 31. So 30 and 31 we have manually verified, right? That is fine. So my larger goal is what about the rest of the terms? Because rest number of terms is infinite, right? I have to just tell that after this thing everything will work. So that is the idea, right? So some basic steps or some initial conditions we can just manually verify, right? That is not a problem.
I see. So after 32, you just want to generalize. That's why.
Right. So 30, 31 I have verified manually. So after 32 everything is possible. So including 30 and 31 also everything is possible. So the thing is 29 is the largest number, so that is not expressible in this form, right?
Yeah, but 36.
Yes, tell.
Would be q greater than 9.
Right. So 36 will be q greater than equals to 9. If I write it is of the form 4q plus r, where r is the remainder.
Yeah, but why do you start at q minus 8?
Yes, q minus 8 is because I want this thing to be positive, because q is greater than equals to 9, so q minus 8 is strictly positive, that I know. And if I take out 32, I know that r is 0, 1, 2, 3. I will get these 4 consecutive cases, and I know the expression of each of them. Okay.
So let's say q is 9. So q is 9, that would be 4q minus 32. So that would be 4q plus r.
Right. So if q is
And
9, yes.
and r could be 0, 1, 2, 3. And q could be any value.
Yes, so q you are taking 9, right?
Oh, q is 9. Okay.
Yes. So if q is 9, then we have 36 plus 0, 36 plus 1, or 36 plus 3, or 36 plus 2, right? So these 4 conditions. So from that 36, I will write it as 4 plus 32. Because for 32, 33, 34, 35, I know the expression. So that will help.
Okay, I think I understand.
Right. So for this, 29 is the biggest one. That is not possible. Fine.
Okay. Yes.
Okay. So the next problem is.
So in that particular case,
Yes.
11. You are deriving all the numbers from 36 onwards, because you can build all the following numbers just from 36.
Right.
But
So,
the 11, it doesn't matter, because you just found a way to build all the numbers
right.
by sets of 4, not by sets of 11.
Right. Because sets of 4 is easy, right? So we'll choose the smallest number
Okay.
between the pair.
Yeah. Okay.
Right. So the next part is. So part D, what they are saying is, so let GCD of AB is 1. Right. So they are telling that using the result from C, means what we have just done, find a conjectural formula in terms of A and B for the largest number not of the form. Yes. So they want to tell. So find a formula in terms of A and B for the largest number. That is not of the form ax plus by. Right. Where both of them are non-negative. So what will be the thing? So let us see what we got. So for these two examples, then you'll get maybe an idea. So from the previous one, it was 3 and 5. So 3 and 5, I got the value to be 7, right? The largest number. So let us write down these 3 examples, then maybe you can see something. So for 3 and 5, A comma B S, we got the largest number that is not expressible is 7. Then when A and B was okay, the first number, yes, 3 and 7, then we got 11, right? So it was 3, 7, it is 11. And finally, when you did 4 and 11, that was 29, right?
29.
Right.
29.
So, yes, we got right. 29.
Yeah.
Yes.
29. Okay.
Right. So from here, can we, can we say something?
Let's see. Like, what's the
Yes.
pattern?
So I think what you can see at least is, okay. So A we have. So can we say something? So 3, 5. AB, if I do the product, then it is 50. Okay. So 3, 7, 21. 4, 11, 44. So is there any relation? So you have to get 7, 11, and 29. Right? Yes. Can you see any relation? I think we can. So there was one more part, right? So that was 5 and 7, right? So we can. So for 5 and 7. So what I recall, that is 23. I can take this as a point also. So 5, 7. What is 35? Right.
35.
Right. So what I can see is here. From here it is more visible. The thing is, if I add these three numbers, right, then it's 21, right? So because 7 and 3 is 10. So same thing for this one, right? So 8 plus 7 is 15, right?
Oh, I see.
So 29 and 15 is also 44, right? So I think this is the this. So what I get is, so let us take the largest number as, okay, so the largest number. Not of the form ax plus by with xy greater than equals to 0 is ab minus a minus b. So this is the conjecture. Okay.
I see. So it is AB minus. Okay.
Right. So now I have to prove the thing that this is actually not represented. Right. So how to prove that? Right. So actually we can use method of contradiction. So we can assume that suppose it is expressible, then get some contradiction.
So we just find any two A and B, like I don't know, 5 and 8, and then
Yes. So GCD has to be 1. That is the condition. So 5 and 8 we can choose. So 5 and 8 is 40. 5 times 8. Then and 5 plus 8 is 13, right? So 40 minus 13 is
27.
right. So 27. According to this, if this is true, then 27 is the largest one that cannot be expressed, and after that everything can be expressed.
I mean, we can just check that like manually, like number
Yes,
by
yes.
number, or
Manually that we can check, but we have to prove the general thing, right? So it should work for any A and B because we are giving a formula. So that should work for any A and B, right? Right. So yes. So let us try to do it. So part A is we have to verify whether this is true or not. So let us assume the contradiction. So suppose AB minus B, this can be expressed in the form of ax plus by, where both x and y are non-negative. Okay. So what we have is ax plus by equals to ab minus a minus b. Suppose x and y I have solution. That is fine. So from here, can we do something?
I mean, why is that an equality, like ax plus by?
Yes. So
Equal
what I am
to,
claiming is that this has an expression of this form, right?
it's like a solution, you mean?
Yes, yes. This can be expressed in this form. So yes, so you can change x and y, but we can keep also x and y. So that is not a issue. You can use maybe capital X, capital Y, or P comma Q, anything you can use, but you can keep x and y also.
Okay. But I mean, AB minus A minus B,
Yes.
it gives us, the. Oh, so you are saying that it's possible to be expressed in that form? Okay.
Yes,
So
we
we
are
are assuming
approaching by
the
contradiction, right?
opposite.
Yes, yes,
We're assuming the opposite. Okay.
yes, yes. And we will show that
Okay.
there is some contradiction. So yes.
Mm-hmm.
So from here, can you get something?
Okay. I see. So we are assuming that it is possible. All right. Okay. But the GCD of A and
Yes, so
B
we
is
know that
opposite.
GCD is 1.
Uh-huh.
Okay, we can try doing one thing. So we can bring the A things on one side, and okay, let us check. So if I bring AX minus AB plus A and minus B minus BY, suppose, then what you have is, if I take A common, then X minus B plus 1, right? And if I take B
Mm-hmm.
common, minus Y minus 1, right?
Mm-hmm.
Right. So now we'll use the condition. So I know that the GCD of AB is 1, right? So A has to divide the other part, right? Minus y minus 1.
A divides minus y minus 1, okay?
Right. So this implies minus 1 minus 1, minus y minus 1 is some AK, right?
Okay.
So for some k greater than equals to 1, that is fine. So then y is nothing but right, okay, let me think. No, so not this one. Is AK something? So now it's AK. Okay, so let us do one thing. So we can directly write like this. So y equals to some AK minus 1, right? Where k is greater than equals to 1 because y is positive.
Uh-huh.
Right? We know that x and y are positive, right?
Yeah.
Okay. So right. So similarly, also we know that b divides the other part, right?
Yeah.
So b divides x minus b plus 1.
Mm-hmm.
Right. So similarly, so b will so eventually b divides x plus 1, right? Because
Yeah.
so b divides x plus 1. So from here I can write that x equals to some k I j k. We can take j. So b times j plus minus 1.
Wait, how did we get rid of minus b?
Yes, yes. So b divides this whole expression. So this part we can ignore, right? Because b and b can cancel out this one, right?
But that would be minus 1 if you divide minus b
Yes,
over minus
yes, yes.
b.
So we are not exactly counting the quotient, right? We are just applying the divisibility condition. So what I meant to say is, so suppose I have 3 divides 17, right? Sorry, this is not true, but 3 divides suppose 18, right? But
Mm-hmm.
18 I can write as 15 plus 3. So this implies that 3 divides 15 also, right?
Uh-huh. So
I
it's
am
just
just
okay.
finding the divisibility condition.
Okay.
So that's why we can replace the thing, right?
Mm-hmm.
Right.
Okay.
Right. So the thing is, yes. So x equals to bj plus bj minus 1, right? Because if I add 1, then b must divide. So this is fine, right?
So wait, that would be b equal to x plus 1 multiply j.
Right.
No, wait. So why x is equal to bj minus 1? It
Yes,
should
yes.
be.
So yes, that I'm saying. So x is positive, I know, right? X is greater than equals to 0, non-negative, right? So x is non-negative. So this it can be expressed in some bj minus 1 because when I add plus 1, this 1 will get
Yeah,
cancelled, right? And b
I
divides.
got it. Yeah, I got it. X plus 1 is equal to bj.
Right, right.
And then that minus 1 goes to the other side minus 1.
Yes, yes.
Okay. Okay.
Okay.
Mm-hmm. Yeah.
So up to this is fine. So then what I can do is, so I know what is x and I know what is y. So let us put back into this form and let us see what happens.
Mm-hmm.
So ab minus a minus b is nothing but ax plus by. So now if I put the things, y is ak minus 1, right? Okay.
Mm-hmm.
So minus b minus a minus b, right?
Yeah, you can get rid of that, right? Because you have
Yes,
that.
yes. So from here what I have is ab is ab times j plus k, right?
Yeah.
But actually this is a contradiction, right? Because from here I got two things, that k must be greater than equals to 1, j must be greater than equals to 1. But that is not possible, right? From here.
Yeah, it's not possible.
So this thing is not possible. So this is our contradiction, right?
Yes.
Right. So this is a contradiction. So since j and k are both greater than equals to 1. Okay. So our original assumption is wrong, and ab minus a minus b cannot be expressed in this form, right?
Yeah.
Yes, but this does not end, right? Because we have to prove that this is the largest one, right? So we have just showed that ab minus a minus b cannot be expressed, but we have to also show that this is the largest one, right? So that how will you show?
I have no idea.
So yes, so this implies that ab minus a minus b cannot be expressed in the form ax plus by with both components greater than 0. Right. Okay. So we have to show that this is the largest one, right? So I think that is the means we can do the next one. The next quantity we can show that whether it is expressible or not. Means whether it is expressible in this form or not, right?
Sorry?
So next term, the term that is just next to this ab minus a minus b. So that has to be representable, right? So that can be. We have to show that that is representable, right?
That is representable. What do you mean by representable?
No, representative means expressed. That can be expressed in this form. That you have to show, right?
But we just conclude that it is not possible to be
Yes,
expressed.
this is not
AB.
possible. What I'm saying is the number that is after this. So.
Or the number after that, you mean
Right.
like a +1?
Right. So this we have to show that we can write it into this form, right? So we have to prove this. This is exist, right? So how to do that?
I mean, we can do the same path.
Okay. Same means which part you will do?
Like we group A on one side and then B on the other side.
No, I don't think that will work because that was a contradiction, right? So now we have to actually show existence of x and y. So we have to prove, means we have to find x and y such that this is thing. So because that was we were doing a contradiction, that expression is fine. Right. So what you can do is, okay. So I know that AB has GCD1, right?
Yeah.
So this is one. So by Euclidean algorithm, I have integers u comma v that can be such that au minus bv, that is one, right?
It was minus, it was plus, right?
No,
AU
plus,
plus.
but we know that one of them has to be minus, right? So I am taking u and v to be positive such that we keep minus.
Yeah, I mean, yeah, one of them must be negative, right?
Right. Okay.
Mhm.
So now also I know the general solution I know. So if UV is a particular solution, then the general solution is U minus KB and V plus KA, right? For some integer K. So this is a solution, right?
That was a solution considering when B is, I mean, that was the solution when you express the Euclidean algorithm as AU plus BV.
Okay. 1 minute. So okay. So you yes. That let us take plus only then. That is fine. So then it is fine, right?
Okay.
Okay, 1 minute. Let me think. So it is we are doing U is replacing by U minus KB. Okay. V equals to yes. I think that is fine. That we can do. Yes. So somehow we have to use this condition to find the solution to the this original one. Okay. So let us see what we have to do. Yes. So AB minus A minus B plus 1. So this one actually will replace by that quantity. So AB minus A minus B plus AU plus BV, right? That we can replace. So then we actually will use some suitable condition. So let us check what to use. So if I take A common, so it is U minus 1, right? So if I take these two things, and if I take B common, then I get A plus B minus 1, right?
Yeah.
Okay.
Yes.
Okay, so from here somehow we have to conclude that both of these expressions are greater than equals to 0. So that you have to do it. Okay. Okay, so let me think about this one. So this one, how to do it. Okay.